Rust tutorial number 4. Ownership, the key concept. This is the most important topic in all of Rust. Once you understand ownership, the rest of the language clicks into place. Most languages manage memory in two ways. Garbage collection, used by Java and Go, is safe but causes pauses. Manual management, used by C, is fast but full of bugs. Rust takes a third approach. Rust uses ownership. The compiler tracks who owns each piece of data. When the owner goes out of scope, memory is freed automatically. No garbage collector. No manual free. No memory bugs. There are 3 ownership rules. Each value has exactly one owner. When the owner goes out of scope, the value is dropped. Assignment transfers ownership, making the old variable invalid. Before going deeper, understand where data lives. The stack is fast, fixed size, and automatic. The heap is slower but dynamic. Simple types like integers live on the stack. Strings store data on the heap. When you assign a string to another variable, ownership moves. The original variable becomes invalid. The heap data does not move. Only the pointer on the stack changes hands. Why move instead of copy? If both variables pointed to the same heap data, both would try to free it when they go out of scope. That is a double free bug. Rust prevents this by allowing only one owner. Think of ownership like a library book. A book can only be checked out by one person. When you give it to someone else, you no longer have it. When the holder leaves, the book returns to the shelf. Not all types move. Simple stack types like integers, floats, and booleans implement the copy trait. They copy automatically on assignment. Both variables remain valid because copying a few bytes is cheap. Types that own heap data always move. String, vec, and box all move on assignment. The rule is simple. If a type manages heap memory, it moves. If it lives entirely on the stack, it copies. What if you need 2 copies of heap data? Use the clone method. Clone creates a deep copy with a new heap allocation. Both variables are independent. Rust makes you write clone explicitly, so you see the cost. Passing a value to a function works like assignment. It transfers ownership. After calling a function with a string, the original variable is no longer valid. This surprises many beginners. Copy types pass to functions without moving. An integer is copied when passed. The original variable stays valid. This is because copying a few stack bytes costs almost nothing. A function can give ownership back through its return value. You can also take ownership in, modify the data, and return it. But this pattern is clunky. Borrowing solves it more elegantly. When a variable goes out of scope, Rust calls drop automatically. This is deterministic. You always know exactly when memory is freed at the closing curly brace. No garbage collector deciding when to clean up. Variables are dropped in reverse order of creation. The last variable created is dropped first. This ensures that dependencies are cleaned up in the correct order. The most common error is use of moved value. You assign a string, then try to use the original. The compiler shows exactly where the move happened and what you can do to fix it. Another common error is use after move to a function. You pass a string to a function, then try to use it. Fix this by cloning before passing, returning the value, or using references. Here is a summary. Move transfers ownership and invalidates the source. Copy duplicates stack values. Clone explicitly deep copies heap data. Drop frees memory when the owner leaves scope. In the next video, we learn borrowing and references. Borrowing lets functions use data without taking ownership. It is the other half of Rust's memory model and makes ownership practical.